So last class we discussed about epsilon delta definition of continuous function, right? So now in this class we are going to discuss a limit of a function at a point. Okay. So the next topic is limits. Suppose we have an interval j, and then we have point a in that interval. So let j is a subset of R, be an interval, and we take some point a in j. Okay. Now we define some function on j except possible for that value a. Except a, we define a function. So we call the function is f. Let f is a function from j difference that singleton a to r. That is, we define a function except the point a. Okay, it's a given function. Be a function. Now, we say that the limit exists as s goes to a. So we say that limit x goes to x goes to a, f of x exists. So when we say the limit exists, if there is a number L in R such that for every epsilon greater than 0, there exists a delta greater than 0 such that whenever if you take any element x in j and the distance between x and a is positive and then strictly less than epsilon, implies that the distance between f of x and f of a is okay, sorry, not f of a, L, because f is not defined on a. Okay, we say L is the limit, then the distance between f of x and then L should be less than epsilon. So this is the definition of limit of a function at a point x equal to a. So when we say limit exists, we can find a L such that the distance between f of x and f of L is less than epsilon whenever the distance between x comma a is less than delta. Okay. Now this, maybe if you look at the in the geometrically, we can say suppose we have a function. Okay. Now suppose we take some point a here. Okay. Suppose our function is something like this, some function f of x. Now, so this is a. If you take the neighborhood of a, but we have to remove this point a, that is deleted neighborhood. Okay. So in the interval, some a plus a minus delta to a plus delta. If we consider a minus delta to a plus delta. Okay. Now, if you take any point between this interval, suppose we take we take some element x in that point, in that interval. Suppose we take x is here. So therefore, the corresponding point on the graph is this point. This is f of x. So this is nothing but actually here. So this is f of x. So suppose this point, maybe this point x after this a or x may be here. Okay, either right hand side or left hand side of a. Okay, anyway, so suppose this x approaches to this point a from the right hand side, or suppose x, to say take x this side, suppose x approaches to a from the right hand side, then this f of x approaches to that value. That means L may be here or here, but the distance between this L and f of x is less than epsilon. Whenever the distance between x comma a is less than delta. So less than delta means what? Very small. Suppose if x approaches to A either from the right hand side or from the left hand side, thus f of x approaches to L. That is actually meaning. So when we say the limit exists at x equal to A, whenever x approaches to A implies that f of x approaches to the point L. This L need not be f of A, okay, because f is not defined on A. Because in the domain we remove A, okay, f of A is not defined. Even though even the function is defined on A, this L need not be f of A. Okay, if L equal to f of A, then such a function is said to be continuous at the point. But actually, this is a meaning. So whenever x approaches to A, then f of x approaches to L. That is the limit. If the limit such a L exists, then we say the limit exists. So limit x tends to A, f of x exists, and it says to be finite value exist, and the finite value is L. Okay. Now, okay, how to check this? Therefore, we have to check two directions. Okay, either from the left hand side or from the right hand side. Okay. Yeah. Suppose we have a line here. We take the point A here. So we are talking about the limit of the function at the point E. But keep in mind the function is need not be defined at that point E. Okay. So for all other points the function is defined. For example, if you take any point less than this A, the function is defined. Again after this A, the function is defined. Maybe like this, they define like this. Now we have to check what happened at the point x equal to E. Okay, that means what? Suppose if you take any point either from the left hand side or right hand side. Suppose I am taking some point x here. Suppose you are moving this point towards A. Okay, therefore the function is defined on x. Therefore, f of x may be here. And suppose if you take point here, therefore maybe somewhere. Okay, anyway, the functions moves like this. Suppose if x increases to A, then f of x approaches to some point. Okay. Again, if you take x from the right hand side and then approaches to A from the right hand side, again for this point we have some function value. If you take this point here, then we have some function value and so on. So therefore, these functions, if x approaches to x to A from the left and right hand side, this function f the corresponding values approaches to some point. Okay. So if the suppose this x approaches to A from the left hand side value, and then this value, suppose both the values approaches to L, that f of x approaches to L, then the limit is exist. That means the right hand side limit also exists, the left hand side limit also exists, and both the values should be L. Then we say the function, the limit exists. Okay, otherwise simply saying limit x tends to A minus f of x. Okay, so that means what? This x approaches from the left hand side. This is a meaning, this notation. A minus A minus means what? X is actually strictly less than Q. Okay. Now this limit exists, and the right hand limit x tends to A plus. That is, x approaches from this direction. Again, the function exists. Suppose both the limits are equal, then we say this limit exists. If both are equal and exist and both are equal, then the limit exists. And what is the value of this limit? Value of this limit. Suppose this also L and this also L, then this also L. Okay. So we have to find the right hand limit and the left hand limit of your function at that point. Okay. So how to find the right hand limit, left hand limit of your function? Okay. We can state in the using sequences. Okay, keep in mind. So your function is defined on the interval, but except that point A. Now what happens if x approaches to A? So there are two directions to approaches to A. Okay. From the right hand side, we can approach from the left hand side, we can approach this to A. From the right hand side, we got to approach this to A in the real line. Okay. But if you take the complex number, if we have some point here, so how many directions? There are uncountable number of directions to reach this point. Okay. There are uncountable number of points to reach the given point. But in the real case, only two direction. Therefore, we can talk about the right hand limit and the left hand limit. But in the complex number, the limit of the complex number is very difficult. We have to check all the direction. But in the real case, we have to check only two direction, either from the left or right. If both limit exist and both have same value, then the limit of the function exists at that point. Okay, got it? Now, that limit should be unique. So once the limit exists, then the limit L should be unique. Okay, that is very important. Okay, now I state the definition using the definition of limits definition in terms of sequences. Okay. So definition. Suppose same thing, let J be an interval, let J is a subset of R, be an interval. And let A is an element of J. So let a function f defined on J except possibly A to R be a function, be given, as a given function is given. Now, then the limit extends to A, f of x equal to L. If you take any sequence xn converges to A, but xn not equal to A converges to this. So then we say limit extends to A, f of x equal to L, if and only if. When we say the limit is L, if and only if you take any sequence in the domain, for any sequence, but the sequence numbers are not equal to A. If you take any sequence xn with xn not equal to A, okay, and again with, but xn converges to A. If you take any sequence xn converges to A, but none of the terms are A, then we have f of xn, we have f of xn converges to L. Then we say L is the limit of the function at the point. So this is just for limit of a function at a point A. So when we say a function f has a limit at a point A, if you take any sequence xn in the domain xn converges to A, but none of the terms of the sequence is A, then f of xn converges to L, then L is the limit of the function at the point. Now this is just for limit. Now what about right hand limit and then left hand limit? Okay. So just you got to take the sequence which is less than A but converges to A. Again f of xn converges to A. That is the right hand limit. Okay. Maybe I state that definition if possible later. Okay, anyway, that is not an issue. Okay, now itself I state that how to find the right hand limit, left hand limit of a function at the point. Okay. So first we call that is okay, right hand limit. So what is the right hand limit of a function at the point? Right hand limit. Right hand limit of f at the point E. So we denote x tends to A plus f of x exists. So when this limit extends to A plus f of x exists. If you take any sequence, for any sequence xn, for any sequence xn in the domain in J, but all the xn's are which is bigger than A and xn converges to A. We have f of xn converges to some point L, then L is the right hand limit of the function. So same definition, only thing you have to take the sequence which is bigger than E but converges to E. Similarly, we define the left hand limit. We have to take the sequence which is less than A but converges to A, then f of xn converges to L, then L is the so we otherwise call L1. So when we say L1 is the right hand limit of f of x, then if you take any sequence xn which is bigger than A and the xn converges to A, and f of xn converges to L1, that this L1 is the right hand limit. So similarly, we define left hand limit. Left hand limit of f at a point A. So we say L2 is the left hand limit of the function at the point A, that is limit x goes to A minus f of x. So when we say this, if you take any sequence, for any sequence xn or yn, you can take anything, that is not issue. So for any sequence xn in the domain J, but all the xn's are strictly less than A and the xn converges to A. But xn converges to A, but all the xn's are strictly less than A, we have f of xn converges to L2. Then L2 is the left hand limit of this. If both the limit exists, then we say limit exists. So when we say the limit x tends to A, f of x exists, if and only if both the right hand limit and the left hand limit exist. Both x tends to A plus f of x and limit x tends to A minus f of x exist, and both values should be equal. Suppose this value is L1 and suppose this value is L2, then L1 equal to L2, and we call some common name L, then L is the limit of this function. Okay. Now this definition very useful to find the right hand limit and the left hand limit. So now we have some exercise. Either you can use the epsilon delta definition, but better if you use the sequence, you can easily solve the problem. Okay. For the exam point of view, work with the sequence. That's very useful. Now there are some theorems we will discuss now. Theorem. Suppose we have a function f, g, h. There are three functions. Let f, g, h. There are three functions defined on j difference that point to R. Okay. Assume that the limit is exist for two functions. The first assumption is, suppose f of x is already we discussed in the sequence, that is sandwich lemma. Similarly here, suppose f of x is less than or equal to g of x, less than or equal to h of x for all x in j difference A. This is the first assumption. And suppose the limit of the two endpoints exists, that is limit x tends to A, f of x exists, and this is equal to limit x tends to A, h of x. Both are exists and same, and suppose we call that value is L, then the theorem says the middle function g of x limit also L. That is sandwich lemma, Askews theorem. So then limit x tends to a, the middle function g of x exists and that value is L. Because we studied in the sequence, suppose xn less than or equal to yn less than or equal to zn, B3 sequence satisfy this inequality. Suppose these two sequence converges to some point L, then the middle sequence also converges to E. That is sandwich lemma. So similarly here, there are three functions satisfy this inequality. Suppose these two functions limit at A, we have L, then middle function also the limit is L. Okay. So this is a sandwich lemma or skews theorem. Same thing. Okay. Very important. Now, suppose the function is defined on A. So, whenever we talk about the limit of the function may not be defined at the point. Suppose the function is defined and the limit is L equal to f of A, then the function is continuous. So, another definition for continuous. Suppose we have an interval defined on a function defined on this. So, write everything. So, J is a subset of R, be an interval. And assume that there is an element A, we fix A is an element of G. So assume that f is a function defined on J to R. That means f is defined on every point of J, in particular A. Okay, so it's a function. So we say f is continuous at E. Then the function f is continuous at the point A if and only if the limit x goes to A, f of x exists, and the limit should be f of A. Okay. If limit x goes to A, f of x equal to f of A, then f is continuous at A. Okay, provided f is defined on that point A and A limit exists. Okay. Now the algebra of limits. So that is we have two functions f and g. Both have limit exists at a point A, then sum of the limit also exists. That is algebra of theorem. So algebra of limits. Algebra of finite limit. Okay, so what is the first statement? Before that, we write the story. Let J be an interval. So suppose we have a function f1, f2 defined on J difference A, where A is an element in J. We define two functions, but A is an element of J, but f1, f2 defined on J difference A. Okay. Assume that the limit exists at a point A for the both the functions. That is limit x tends to A, f1 of x exists. We call that value is L1, and limit x tends to A, f2 of x. This limit also exists. We call L2. Okay. Now the first one, the sum of this one. So we know how we define f1 plus f2 is nothing but f1 of x plus f2 of x. Then limit x tends to A, f1 plus f2 at a point x is exist. The value is nothing but L1 plus L2. Suppose if multiply with some scalar, then limit x tends to A, some alpha times f1 of x. That limit of this function is nothing but alpha times limit of f1, that is L1. Now product of these two functions, then limit x tends to A, f1 into f2 of x. What is the limit of this product function is nothing but product of the limits L1 into L2. We can define quotient also, provided it should be non-zero. Okay. Suppose assume that L1 is non-zero. The number if L1 is non-zero and this f1 of x is not equal to 0 for all points in the delta neighborhood, then limit x goes to a 1 by f1 of x is exists, that value is nothing but 1 by L1. Provided L1 is non-zero, each f1 of x is non-zero. So these are all algebra of limits. Okay. Now, what about the composition? Okay. So next theorem. Suppose we have a limit of a function at the point a. So limit x goes to a, f of x is some alpha. Okay. And g is a new function. It's defined on some interval. Okay. Maybe we take some interval I. But I to R. But this I contains this alpha. Alpha should be the member of I. Okay. Now already f is defined on some j not contained in A, but alpha is the limit of f. Now we suppose you have a g is a function defined on this interval containing alpha and continuous at the alpha. Okay, so we suppose we have a continuous function g. It's a continuous function at a point alpha. Then the composition limit. Then limit x goes to a g composition f at x is nothing but this exists actually. This exists and its limit is g of alpha and it is g of alpha. Okay. Now maybe we solve some problems to find the right hand limit and the left hand limit of the function. Examples. Suppose we define f is a function from R star. So R star means what? We have to remove 0 from R. To R, we define a function R star to R defined by f of x equal to x by modulus of x. Okay? X by mod x, that is a function. Now, so the function is not defined at 0. Therefore, we are expecting what is the limit of the function at the point 0. Then now our aim is to find the limit x goes to 0 f of x. We have to check this limit exists or not. So for that we have to check what is the right hand limit and the left hand limit. If both the right hand limit, left hand limit exist and both have same value, then limit of this function exists at the point 0. So first we have to find the right hand limit. So limit x goes to 0 plus f of x. So limit x goes to 0 plus f of x. So what is the meaning of this? If you take any sequence, xn which is greater than 0, but xn converges to 0, okay, then f of xn converges to where? That limit of f of xn is the limit of this one, right hand limit. So all the xn's are positive, but xn converges to 0. Okay. Now, what is f of xn? By the definition of f of xn, xn by modulus of xn. But xn's are positive, therefore modulus of xn is nothing but xn. Therefore, xn is cancelled. We have 1. Therefore, f of xn is the constant sequence 1, 1, 1 is converges to 1. Therefore, now we found that the value is 1. The right hand limit of the function at the point 0 is 1. Okay. I'm not taking any particular sequence xn. If you take any sequence xn greater than 0, but xn converges to 0, at f of xn should be 1. Okay. Now, what is the left hand limit? So, limit x goes to 0 minus f of x. So, limit exists or not. If it is exists, what is the value? So, that means what? If you take any sequence xn which is less than 0 and the xn converges to 0, then what is the limit of f of xn? Now, f of xn by the definition, xn by modulus of xn. Okay, but xn's are negative. Therefore, what is the definition of modulus of x? So quickly we can recall x if x is positive, minus x if x is negative. Since here xn's are negative, therefore modulus of xn is nothing but minus xn. We can cancel xn, we get minus 1. Therefore, f of xn is the constant sequence minus 1, minus 1, minus 1 is converges to minus 1. Therefore, this is the left hand limit of the function at the point 1. Now, both the right hand limit and the left hand limit exist but not equal. Okay, therefore, the limit of the given function is not does not exist at the point x equals 0. Okay, anyway, right hand limit, left hand limit exist, but both are different value. Okay, therefore, the limit does not exist. Got it? So, therefore, limit x tends to 0, f of x does not exist. Because since the right hand limit of your function at the point 0 not equal to the left hand limit of your function at the point. If both are equal, then the limit of the given function exists. If both are not equal, then so maybe you will study in the continuous. Actually, there are some kind of continuous discontinuous function. Okay, so both are equal exist but not equal, that is a discontinuous first kind, and none of the either the right hand limit nor the right hand limit exists, then it says a discontinuity of second kind. Okay, anyway, we discuss that. Now we discuss another example. So you can use the epsilon delta definition to check that to show that this limit does not exist. Okay, but this is very simple if you work with the sequence. So
Right
second one,
side and left hand side limits are
sorry,
existing. So,
sorry,
so here why limit does not exist, sir?
because right hand limit, left hand limit exists but not equal. This is minus 1, but the right hand limit is plus 1. Both exist and should be equal, then only the limit of the function exists at the point.
Okay, sir.
But the right hand limit is different value, left hand limit is different value.
Okay, sir.
That's why the limit of the function does not exist. Okay, got it? Yeah. Now we discuss another example. Okay, suppose we define a function f of x equal to modulus of x for x non-zero value. For non-zero value is defined f of x equal to mod x. So what about the zero value? For x equal to 0, we define 23. That means what? F of 0 is 23. Now, what is the limit of your function at the point x equal to 0? Do you understand my question? The function defined for non-zero values is defined to be modulus of x. It is actually modulus of x. Confusion, we can erase this. Mod x for non-zero value. For zero value, we take 23. Is nothing but this. Now, what is the limit of the function at the point x equal to 0? Now, we got to find the right hand limit, left hand limit. So what is the right hand limit? So if you take
Modulus of
any sequence xn, uh, if you take any sequence xn which is less than 0, and but xn converges to 0, what is f of xn converges? But what is f of xn? By the definition, modulus of xn, because each xn's are non-zero. Therefore, it's modulus of xn, but everything is negative. Therefore, what is the modulus of xn? Is minus xn.
minus.
But anyway, xn converges to 0, modulus of x minus xn also converges to 0, right? Therefore, the left hand limit is 0. What about the right hand limit? That means what? If you take any sequence xn which is bigger than 0, but xn converges to 0, then what is f of xn? Again, f of xn is nothing but modulus of xn. All the xn's are positive, therefore modulus of xn is nothing but xn. But already we know that xn converges to 0. Therefore, the right hand side limit also 0. So both the right hand limit exists, left hand limit exists, and both are equal. That value is 0. Therefore, limit of the function is 0. Okay. So can you say this is a continuous function? If it is
No.
continuous, no. If it is continuous, it should be equal to f of 0. Okay. But what is the f of 0? 23. Therefore, this function is not continuous. So I already said that when the function is continuous at a point a, limit x tends to a, f of x exists, and that should be equal to f of a. But f of 0 here, 23, but we get 0. 0 is not 23. Okay. Therefore, this function limit exists at the point x equal to 0, but not continuous at the x equal to 0, because that is not equal to f of 0. So this is not equal to f of 0. Therefore, this function is not continuous. It is very important for checking continuity at a point x equal to e. Therefore, this function. So just to draw the graph, you can easily understand the function. Look at the graph of the function. So actually, this is modulus of x. Okay, almost modulus of x graph, but except the point x equal to 0. Therefore, the graph look like except the 0. So mod x graph, but at the point 0 is like this, but at the point 0 is definitely to be 23. So there is a discontinuous, there is a jump at the point x equal to 0, right? So for all, this is a mod x graph, except, so for the 0 point, is mapped to be 23. So from the graph itself, you can see that, okay, at the point x equal to 0, the function is discontinuous. Okay, for all other points, the function is continuous. But at the point x equal to 0, the function is discontinuous. Either you can see the picture, or you can we find the limit is 0, but that is not equal to f of 0, because we define it to be 23. Okay, good. Now, next problem. So, any doubt in this? Uh, and then, okay. Yeah. Any doubt? To find the right hand limit, left hand limit. Maybe we take some more example. Okay. And then we check it. What happened. So, fourth or third example. What is the limit x goes to 0, 1 by x square? Can anyone? Limit x goes to 0, 1 by x square. Okay. Now find the right hand limit, left hand limit. So that
Zero,
is if
sir.
take, yeah, why? Why?
One by
Huh? Sorry? 1 by 0 is infinity. Okay, so first you have to find the right hand limit. That means if you take any sequence xn which is less than 0, but xn converges to 0, you have to find what is f of xn or the left hand limit. So since by the definition of what is our f of x, so So f of x is nothing but 1 by x square. That is our function. So therefore this is 1 by xn square. Now this converges to where? Why you get 0? Infinity or 0? Because what xn converges to 0, then that means what? Xn's are very small. That is very close to 0. But 1 by xn square, sir.
Also close to 0, sir.
Why? Suppose, for example, if you take 1 by 2, xn equal to, for example, 1 by 2. What is 1 by xn? Is 2. Is away from 0, not close to 0. Suppose I am taking 1 by 10 lakhs or something. This is very near to 0. But what is 1 by xn? Is 10 lakhs or 10,000. It's bigger number, right? Xn's are small, therefore 1 by xn's are bigger. Therefore, it goes to infinity, approaches to infinity. Got it? Even if you take xn's are positive and the xn converges to 0, again 1 by xn square converges to 0, infinity. Therefore, this should be infinity. Any doubt in this? Okay. Suppose instead of, yeah, any doubt?
Understood, sir.
Okay, now limit x goes to 0 plus 1 by x. What is the limit? Again, what is the left hand limit of the function 1 by x? Can anyone tell me that? So what is the right hand limit of the function 1 by x? What is the left hand limit?
Infinity.
Which one? Infinity? Both are infinity, yeah.
The left hand limit, it will be minus infinity. Or
Yeah. This should be minus infinity and this should be plus infinity. Okay. Why? So this means what? If you take any sequence which is bigger than 0, but xn converges to 0, what is f of xn? But f of xn is nothing but 1 by xn. Xn's are very close to 0 and everything is positive. Therefore, 1 by n is bigger number. That is, this approaches to infinity. Therefore, the right hand limit is infinity. So in this case, if you take any sequence which is less than 0, but xn converges to 0, then what is f of xn? Again, f of xn is nothing but 1 by xn. But again, xn's are negative number. Therefore, and the xn's are very smaller. That is very close to 0. Therefore, 1 by xn is away from 0. But everything is negative. Therefore, it's away from 0, that is converges to minus infinity. Because all the xn's are negative number, 1 by xn's are away from 0, therefore should be minus infinity. Therefore, the left hand limit is minus infinity. Got it? Okay.
yes.
So that is very important. First of all, you have to find the right hand limit and then left hand limit of the function. And then you have to conclude that the limit exists or not. Okay. Now we define some f is a function from R to R. Okay. Maybe I can ask R. Remove 0 from this. Okay. Then I am defining a f of x equal to, here x is non-zero because we are removing 0 from R, that is R star. We define sin x by x. Sin x by x. Now we are talking about what is the limit of which point? What is our interest? To find the limit of which point? So because the function is not defined at the point 0, therefore we are expecting what is the limit of the function at the point x equal to 0. Now what is the limit?
1.
1. But why? So limit is 1. So if you study the L hospital rule, if substitute x we get sine 0 by 0, that is 0 by 0. We got to differentiate numerator and the differentiate denominator. After that, you got to substitute x equal to 0, we get 1. But still, we are not studied that topic. But you have to apply, you have to find the right hand limit and the left hand limit. You will find that thing. Okay. So anyway, the limit is 1. Now, do you want more example or we go to the next? Okay, maybe I consolidate the definition of the limit. We draw some flow chart. Okay, so what is the flow chart? First, the limit. Yeah, yeah. Tell me.
Sir, I have one sum, sir. We'll do
Yeah,
that, sir.
yeah. Tell me. You try. Yeah, what is the sum?
Sir, I've shared it in the group.
Okay. So you send that the question, right? Okay. So now, yeah, find the right hand limit, left hand limit of this function. But we have to work more. You should know that. Okay. Anyway, I read the problem. So what is the f of x equal to x plus modulus of x into 1 plus x whole divided by x into sine of 1 by x. X is non-zero. For non-zero point, they define this. Now they call L equal to the left hand limit. That is limit x goes to 0 minus f of x. And then R is the right hand limit. Limit x goes to 0 plus f of x. Then which one of the following is true? L is exist, but R does not exist. All the things. Okay. Now, actually, there is some. We have some theorem. If you prove that theorem, we can easily check that this is true or what is the limit or something. Okay. Because if you know one sequence is actually the limit x goes to 0 sine 1 by x. So the limit is not exist actually. So limit x goes to 0 sine of 1 by x. Okay. So this limit is not exist. That does not exist. But there is some theorem. What the theorem says, suppose limit of f of x into g of x, if you study the L hospital rule, you can know this here. So what is the limit of, I can say, suppose I'm saying the limit is 0, when one of the functions should be bounded function, bounded, and another function limit is 0, then the product function is 0. Okay, keep in mind. So one function is bounded function, another function limit is 0, then the product goes to 0. So we are going to use that idea here. See, because sign is always bounded. Okay. Therefore, we have to check. We have to adjust this into here. We can cancel x and then maybe better we discuss this problem later because we have to prove some theorem. We have to use some theorem to prove this. Okay. Anyway, we will discuss it. But this result you should You should keep even for cos 1 by x or sin 1 by x is always actually it's oscillates between minus 1 and plus 1. The limit does not exist for this case. But we use some theorem. If you multiply with some function whose limit is 0, then the product is 0. Okay. Okay. Now, okay, end of this unit limit chapter, we discuss this problem. So we try to finish all the theorems and then we come to here. Okay. Okay, because sine 1 by x is very, it's not converges. The limit of this one is not exist. But if you product with some bounded function, that will be, the limit should be exist. Okay, now I read the some flow chart of what we discussed in the limit. Okay. Suppose when we say the limit x goes to a, f of x equal to n. So there are two cases. This limit a may be, so there is a, another one is the limit is l. Okay. So there are two cases. If a is finite or infinite. Similarly, l is finite or infinite. There are two cases again. So for a, we have two cases. A is finite and a is infinite. Similarly, for L is finite, L is infinite, infinite limit. If A is finite, then we have two cases. We can talk about the right hand limit. Again, we have talk about the left hand limit, and then we can talk about the limit of the point. Okay, if the right hand limit, left hand limits are equal, then this is equal to limit of the function. So in the A is infinite, there are two cases: minus infinity, plus infinity. A goes to minus infinity, A goes to plus infinity, and so on. Right? There are two cases. Similarly, for if L is finite, it's not an issue. If L is infinite, then there are two cases. Either the value is minus infinity or plus infinity. Okay. Now we can write the definition accordingly to all the things. Okay. So we move to the next thing. Good. So another way of saying the right hand limit definition. So theorem. So let J is a subset of R be an interval and the f is a function defined on J to R is an increasing function. So assume that it's increasing. Assume that C is an element of J. Assume that C is in J, but not the endpoint of J. C is not an endpoint of J. Then the right hand limit of the function at a point C is, so the limit x goes to C plus f of x actually is nothing but LUBR, that is supremum of f of x, but all the values should be less than C, where x is an element of J. So you have to find f of x for all x less than C and then take the supremum, that is the right hand limit. So the left hand limit is infimum of x tends to C minus f of x, but the infimum or greatest lower bound, the infimum of all f of x but all the x are which is bigger than c, and x is an element of G in the interval. Okay. So the right hand limit, left hand limit is nothing but infimum and supremum of this collection. So if it is continuous, both the values should be equal. That means the supremum and the infimum should be equal. Okay. Now, maybe I go to some other book that contains some other solve some problems using continuity. Again, we have to discuss about the LHospital rule also. Okay. Now, some examples are we can easily solve the problem. Okay, so for example, if you consider this function, so exercise limit x goes to a x square minus a square by x minus a. So what is the limit of this one? So first you have to simplify this. So in the numerator we can rewrite x plus a into x minus a. By denominator we have x minus a. We can cancel x minus a. Then if x approaches to a, then what about x plus a? Just add a, we get 2a. So therefore this limit is 2. We can cancel this x minus a. Okay. This is the first problem. Now, second one. Suppose we have a function like limit x goes to 0, x into sine of 1 by x. Okay. Then what is the value of this? So this should be 0. So that's why I'll say the theorem. Suppose we have a function g whose limit at a point a is 0 and f is any function, but it should be bounded by some number, bounded function, then limit x goes to a, f of x into g of x should be 0. So I think maybe it will state in somewhere, but this is an important here. Okay. Maybe I found that theorem. Yeah. Maybe I wrote the theorem. Otherwise, you can use the epsilon delta definition. You can prove that the limit is 0. Otherwise, simply use the theorem. You can prove that since sine is bounded, limit x goes to 0, x is 0. Therefore, the product is 0. Okay. So, I read the statement here. Theorem. Suppose if limit x tends to a, f of x is 0 and g is bounded and g of x is bounded in some deleted neighborhood of a. In some deleted neighborhood means what? You have to remove a from that interval neighborhood. In some deleted neighborhood. Neighborhood as in a minus epsilon to a plus epsilon open interval. Okay. So neighborhood. Deleted neighborhood of a. In that neighborhood, g is bounded. Then the product function limit is 0. Then limit x goes to 0, x goes to a, f of x into g of x should be 0. So therefore, using this theorem, we can easily prove this problem. We can easily solve this problem because sine of anything, 1 by x or anything, is always bounded by 1. This is our g. This is our f. As x goes to 0, x goes to 0. Therefore, limit of f of x is 0. Therefore, by this theorem, we can show that the limit of x into sin 1 by x is 0. Okay. This is one important theorem. And suppose the limit of the function is L, then limit of modulus of f is nothing but modulus of L. That is another theorem. So if limit of a function at a point A, f of x is L, then the limit x goes to A, modulus of f of x is modulus of L. But converse need not be true. Why the converse need not be true? That is modulus of f limit exists, but f limit does not exist. Why? So example for that, we consider the function f of x is 1 if x is less than a, for minus 1 for x greater than a. Now what about at a point x equal to a? Now what is of modulus of f of x is nothing but just 1. So therefore, if we take limit x goes to a, so it's nothing but limit x goes to a, modulus of f of x nothing but just 1. Since this 1 is independent of x, therefore we get just 1. Okay. Therefore, limit exists, that value is nothing but 1. But the given function limit is not exist. Why? So that is the right hand limit values we get 1, the left hand limit values will get minus 1. Therefore, the limit of the function is not exist. Therefore, the converse of the theorem may not be true. If modulus of f limit exists, but f limit does not exist, may not be exist at the point x equal to. This is a important theorem. And then suppose the function, there are two functions f and g. F is bigger than g, and then for limit of f, limit of g. So theorem, maybe state before that state the theorem. Suppose f of x function is greater than or equal to 0 for all points. Okay. And suppose limit exists. If the limit x goes to a, f of x exists, then maybe we call that limit is L. Then the L should be greater than or equal to 0. The limit also greater than or equal to 0. If the function is greater than or equal to 0 for all points, and if the limit exists at a point x equal to a, then limit is also greater than or equal to 0. This is our theorem. Now, the corollary of this theorem, suppose we have two functions f of x and g of x satisfy the condition g f of x is greater than or equal to g of x for all x, and both have limit exist. That is, if limit x goes to a, f of x is some value L, and limit x goes to the same point a, g of x equal to some m, then the theorem says L is bigger than or equal to m. So limit of f is greater than limit of g, if f is greater than g. Even if you take strictly greater than g of x, but still the limit is greater than or equal to m. Now, we solve some problem to find the right hand limit and the left hand limit of a function, or limit of the function. And then we solve the problem we balance. Now first we find the limit of this one. So limit x goes to 0, x minus mod x by x. So first you have to check the limit exists or not. Okay. Now we have to find the right hand limit, left hand limit of your function. Now what is the right hand limit? If you take any sequence xn which is bigger than 0 and the xn converges to 0, then what is f of xn? So what is our function f of x? F of x is nothing but x minus mod x by x. So what is f of xn? Xn minus modulus of xn by xn. Since xn is positive, therefore modulus of xn is xn. Therefore xn minus xn is 0. Therefore this is 0. 0 sequence is converges to 0. Therefore now we found that the right hand limit is what? 0. Now what is the left hand limit? So that is what, if we take any sequence xn, so this is right hand limit, right hand limit RHN. So left hand limit. If you take any sequence which is less than 0 and the xn converges 0, then what is f of xn? What is the limit of this f of xn? F of xn is nothing but xn minus modulus of xn by xn. But the xn's are negative, therefore modulus of xn is minus xn. So minus minus plus, we have 2xn in the numerator, denominator we have 2xn. Xn is non-zero, we can cancel it, we have 2. Therefore 2 is a constant sequence 2 to 2 is converges to 2. Therefore the left hand limit is 2, the right hand limit is 0. Both limits exist but not equal. Therefore the limit of the function does not exist. Any doubt?
No, sir.
Okay, now I ask one more question. So second example. Suppose f is a function from R1 defined by f of x equal to 3x minus 2. 3x minus 2 for x is less than 1. For x greater than 1, we define 4x square minus 3x. Now, what is our aim? What we have to find? We have to find the limit of what?
Limit x to
X tends to
1.
which point? Sorry?
Once.
1. Yeah, very good. Now, what is the limit? If it exists, what is the value? Now, you have to find the right hand limit, left hand limit. So, what is the right hand limit value? That is, we take any sequence xn which is bigger than what?
1.
1. And the xn converges to 1. Now, what is f of xn? What is f of xn? Since all the xn's are which is bigger than 1. So, that means what in the second case? Therefore f of xn is nothing but 4xn square minus 3xn. Now, where this converges? Since xn converges to 1, therefore xn square converges to 1 square, that is 1. 4 times xn square converges to 4. Now, what is the answer? This converges to what?
1, sir.
1. Yeah. Now, what is the left hand limit? If you take any sequence xn which is less than 1 and the xn converges to 1, now what is f of x?
So that also.
Huh?
So
Sorry?
3 minus 2, 1, sir.
Yeah,
For
3xn
left
minus
hand.
2. This is converges to 1. Therefore, both right hand limit, left hand limit exist and both should be equal. Therefore, the number is the limit. Therefore, limit x goes to 1, f of x value is 1. Okay, good. Now, maybe I will ask some more. We ask some more problem and then we can solve it. Okay. So maybe it's the fourth or fifth. It's third problem. So find limit x goes to a f of x. where f of x is the value of x. If 0 less than x less than a, in this interval, we define x square by a minus a. Now, if x equal to a, the function is defined to be 0. If x is bigger than a, the function is defined to be a minus of a cube by x square. Now, what is the limit? X goes to a, f of x. Now, what is the right hand limit? Left hand limit. So, therefore, the function is defined on which interval? Since it start from 0 and then goes to infinity, therefore, it's dependent on 0 to infinity. Wow. Okay, therefore, all the x's are positive. Now, what is a right hand side limit? Right hand limit. So, we have to find the limit of the function at a point x equal to a. Therefore, if we take any sequence which is bigger than a and the xn converges to a, then what is f of xn? What is f of xn?
0,
a,
sir.
a minus
It's an
a cube by xn square. This goes to 0 because we get a. Okay. Now, what is the left hand limit? You take any sequence which is less than a and the xn converges to 0, sorry, xn converges to a, then what is f of xn? It is in the first case, xn square by 2 minus a. This goes to where? A square by 2, right? Oh, sorry, actually, this is actually x square by a. No, sorry, x square by a. Therefore, again, this goes to 0.
0.
So, both right hand limit, left hand limit exist. Both should be equal to 0. Therefore, the limit of the given function, the point x equal to a is 0. Got it?
Yes, sir.
Okay, maybe the final problem. Then we stop. So, fourth one. Limit x goes to 0, x into e power 1 by x by 1 plus e power 1 by x. What is the limit? So you don't need to always find the right hand limit, left hand limit. You have to apply the algebra limits. If you know limit of some function and the limit of another function, then just the limit of sum is the sum of the limits. Okay. So first you got to, so what is limit x goes to 0 e power so yeah, so roughly x very near, so x is very near to 0. Okay, x is very near to 0, then 1 by x goes to where? Near to
Infinity.
infinity, then minus 1 by x near to minus
Minus
infinity,
infinity.
then e power minus 1 by x near to,
E power minus infinity.
that is, what is the value? Look at the graph e power x and then tell me what is e power. If x goes to infinity, what is e power 1 by x? So this actually, so what is the graph of e power x? Actually, this is a graph of at the point 1, and this line is very close to this x-axis. So this is actually negative, right? If x is increasing, this line is very close to x-axis. That means what? 0.
E power infinity is infinity, sir.
E power minus infinity. E power infinity is infinity. Not e power infinity actually. E power x goes to infinity as x goes to infinity. E power minus x goes to 0 if x goes to infinity. Okay, so therefore this goes to 0. It's very near to x axis. Therefore, this as negative side is x goes to minus infinity side, then e power this goes to 0. Okay, therefore the limit is 0. Now apply this. Now solve it. What is the idea? You can cancel this e power 1 by
Limit is
x.
0, sir.
Sorry, limit is 0, right? You can take
Yes.
because you can take okay, you can take e power 1 by x from the denominator. We have 1 plus 1 by e power 1 by x, that is e power minus 1 by x. So we can cancel this. We have x by this. So we know that limit of this divided by limit of this. So limit of this is 1, but limit of this is 0. Therefore 0 by 1 we get 0. Okay. Now you get some idea about right hand limit, left hand limit, right? So there are some more problems there. We will discuss in the next class, and then just try that problem. What you send that problem, you just try now. You get some idea, and then find the right. Okay. If you not get, we will discuss that next class. Okay. Thank you.